Hello everyone, we are from Section 1 Group 12. Our topic of this project is flash calculation to separate mixture between ethane and propane. Our group member have me, Yanda, Sim In, Kritish and Hong In. Alright, let's have a look to flash distillation. In this method, the liquid mixture is partially evaporated, the vapor and liquid are equilibrium and finally sampled separately. The advantage of flash distillation is a useful method for separating the pure component from multi-component systems such as crude oil, with the range of boiling point is small. The disadvantage of this flash distillation is the similar volatility cannot be separated. The binary system, as it is not efficient way to obtain a completely pure component. The application of this flash distillation is where the multi-component system are processed in pipe steels is often used in the petroleum industry, as in this project we need to separate the ethane and propane. Okay, here is the simple diagram of flash distillation. Before it go to the flash distillation, the feed is heated at the turbulent heat exchanger, as shown in here, and then the hot liquid mixture is then fed through a pressure reducing valve to a separator where the pressure is reduced to adiabatically produce vapor at the expenses of the liquid. The liquid is withdrawn from the bottom of the separator while the vapor exists at the top of the separator and it is condensed at the condenser.
In this part, we need to determine a few process and typical process conditions, which are overall composition, operating pressure, and operating temperature of the mixture. In this project, we assume that it is equimolar composition. Therefore, the composition for both ethane and propane is 0.5 mol. By calculating the average temperature between the boiling point of ethane and propane, we assume that the operating temperature is negative 70 degrees Celsius. Because it is lower than average boiling point and not only vaporization occurs. Firstly, we need to calculate the bubble point pressure by using the formula given. The vapor pressure for both ethane and propane are shown in the table, and its calculation will explained by other member later. Therefore, we get the bubble point pressure which is 137.2695 kPa. Secondly, to find the ring point pressure, we use the formula given and we get 44.3164 kPa. In this project, we assume that the operating pressure is between the bubble point pressure and ring point pressure. Therefore, the operating pressure is 90 kPa. It is important to exist as an equilibrium mixture of vapor and liquid to carry out flash calculation.
Okay, so now moving on to our flash calculation part. In this calculation part, we are going to find the mole liquid, mole vapor, liquid phase mole fraction and also the vapor phase mole fraction for our mixture, ethane and also propane. Before we go further to our calculation part, now let's see our basic information of mixture, ethane and also propane. So here is the boiling point, the composition and also the system condition that will be used in this calculation. So first, we need to find the P saturated for both ethane and also propane by using an Anton equation and also a constant table that we find from internet, table A1 shown below. Okay, so by referring to the table A1, we can now substitute the A, B, and C constant into this Anton equation in order to find the P saturated for ethane and also propane. So for P saturated of ethane is 250.228 kPa, while for propane is 24.311 kPa.
By definition of this law, we can calculate the K value when the vapor pressure divided by the operating pressure. Therefore, K1 is 2.7803 kPa, while K2 is 0.2701 kPa. From equation 13.18, we can find the molar composition of liquid for ethane is 0.2908, while for propane is 0.7092. From equation 13.16, we can calculate vapor phase mole fraction by multiplying K value with S value. Therefore, the vapor phase mole fraction for ethane is 0.8084, while for propane is 0.1916.
Okay, so now let's proceed with equation 13.107 in order to find the mole liquid and mole vapor of mixture. So now, first of all, we're going to arrange the equation of x1 into equation of V initial, and then we're going to substituting all the components from previous calculation into this equation to find the V initial. And last, the V initial that we obtain is 0.4041963 mole. After obtaining the V initial value, now we can use the iterative solution to find the value for mole of vapor V of mixture. And the equation shown on the right side, the V equation, is for us to do the iteration. A total of 7 times iteration are required to get a constant V value, and this constant V value also equal to the mole vapor of mixture, which is 0.4042 mole, while for the mole of liquid of mixture is 0.5958 mole. Okay, so now let's look at the graph of TSY and also PSY. So for the left side is the graph of TSY, and for the right side is the graph of PSY. So for both graphs, the blue line represents the mole fraction of liquid phase, while for the orange line, it represents the mole fraction of vapor phase. So for the left side in the TSY graph, the temperature decreases as the mole fraction of ethane increases. Next, for the PSY graph, the pressure increases as the ethane mole fraction increases.
Okay, now I'm going to explain about the safety issues for the flash collar. First one is the flammability. We use ethane and propane. So ethane and propane is highly flammable gases. During the separation process, it is critical to guarantee correct handling and control of ignition sources. So second one is pressure hazard. Ethane and propane are typically handled at high pressures and may cause some casualties such as equipment failure, leaks and ruptures. Third one is toxicity. Although ethane and propane are not highly toxic, they can also displace oxygen in poorly ventilated areas, leading to asphyxiation. Fourth one is cryogenic hazard. Ethane and propane are liquefied under cryogenic condition. Extreme cold temperature can cause burns or frostbite upon contact with skin or other material. Okay, now I'm going to explain about the conclusion, which is the summary of the data after we do the calculation. This is our flash column. In the feed condition, we got ethane with 50% and propane 50%, which is both is equimolar. And for the top stream, which is gas, ethane we got 80.84% and propane we got 19.16%. And for the bottom stream, which is liquid, ethane we got 29.08% and for the propane we got 70.92%. These are the reference we used when we do the calculation. Thank you for watching everyone by Group 12.